So we're here today to film your Uniform Circular Motion Lab. This is the apparatus here. It's a tube with some fishing line going through it. On one end is a rubber stopper that I stole from the Chem Lab. Don't tell Mr. Risner on me. And on the other end, I'm going to be able to hang some weights. So basically what we're going to do is we're going to get that rubber stopper moving in a circle, and the tension that is provided by the hanging weights are going to allow that rubber stopper to continue moving in the circle. So we're going to film a bunch of trials with different masses, and we're going to count how much time it takes for 10 revolutions, and that'll allow us to find the period, which is the time for one revolution. And the last thing we'll need to do is just grab the thing so we can measure what the radius was. So when I get this thing spinning in a horizontal circle, I can actually feel that requiring tension in the string, which I'm actually pulling down with my left hand. So when I start filming data for you, it's going to look a lot like this, except my left hand is going to get replaced by some hanging weights. So we'll know exactly how much force of weight there is, so we'll know exactly how much tension there is, and then we're going to calculate and compare that to our centripetal force. All right, here we go. Okay, and it looks like the mass of that rubber stopper is 19.57 grams. Okay, I'm starting with 100 grams, and my lab assistant is going to start timing. On your mark, get set, go. Stop. That was 20 revolutions. And the radius that I'm measuring to the center of that rubber stopper is 98 centimeters. 98 centimeters for the radius. And the time was 17.12 seconds for 20 revolutions. So I've increased that to 150 grams. Let me get that balanced. And my assistant is going to start timing right now. Stop. That was 20 revolutions. When I get this unwrapped around my head, I will measure the radius. That is, I'm going to call it 105 centimeters. This is 200 grams hanging. It's pretty well balanced, and my assistant's going to start timing right now. Stop. That was 20 revolutions. The radius is 77 centimeters, and the time is 10.7 seconds. Here goes 250 grams. On your mark, get set, go. Stop. That was 20 revolutions in 9.85 seconds. And the radius is 66 and a half centimeters. 66 and a half. Okay, here goes 300 grams. Get that balanced. On your mark, get set, go. Stop. I think I might have lost the radius on that one, I'm not sure. Nope, I think I got it. That was 20 revolutions in 9.69 seconds, and the radius is 82 centimeters. 82 centimeters. Okay, we're gonna try 350 grams. Hopefully that's not gonna break the string. On your mark, get set, go. Stop. That was 20 revolutions in 8.39 seconds, and the radius is 56 centimeters.